Now we'll talk about facility location analysis. The transportation method has proved to be especially useful in helping a firm decide where to locate a new factory or warehouse. Since a new location is an issue of major financial importance to a company, several alternative locations must ordinarily be considered and evaluated. Even though a wide variety of subjective factors is considered, including quality of labor supply, presence of labor unions, community attitude and appearance, utilities and recreational and educational facilities, a final decision also involves minimizing total shipping and production cost. This means that each alternative facility location should be analyzed within the framework of one overall distribution system. To determine which of locations should be selected for a new production facility, linear programming can be used. The case that we are going to look at is Hargrave Machine Company. The Hargrave Machine Company produces computer components at its plants in Cincinnati, Salt Lake City, and Pittsburgh. These plants have not been able to keep up with demand for orders at Hargrave's four warehouses in Detroit, Dallas, New York, and Los Angeles. As a result, the firm has decided to build a new plant to expand its productive capacity. The two sites being considered are Seattle and Birmingham. Both cities are attractive in terms of labor supply, municipal services, and ease of factory financing. The important question that Hargrave now faces is this: which of the new locations will yield the lower cost for the firm in combination with the existing plants and warehouses? Note that the cost of each individual plant to warehouse route is found by adding the shipping cost. And the shipping cost information is given right here. So these are source cities, these are the warehouses and destinations, and the costs are given here. Of course, this has to be researched thoroughly, and this number has to be accurate. And we also have production cost available, and monthly supply and demand data is available. And through your research, you have to determine this number accurately. When these numbers go wrong or inaccurate, the calculation has to change. To determine which new plant, Seattle or Birmingham, shows the lower total system-wide cost of distribution and production, we solve two transportation problems, one for each of the two possible combinations. In other words, we want to put Seattle first and then solve the linear programming and find whether it produces a lower result than the other alternative. Then we put Birmingham option into the linear programming and solve for it and find whether it is working or not. And compare two results and choose the one with the lower cost. That's the strategy that we are going to use. So let's first define the variables first. We have let xij, the number of units shipped from source I to destination j that I mentioned before, and I is represented by 1 Cincinnati, 2 Salt Lake City, 3 Pittsburgh, and 4 Seattle. And we have now also four destinations: Detroit, Dallas, New York, and Los Angeles, right? So these are the variables. And we can now, later when we are working, we can replace Seattle with Birmingham and then do the same calculation. And if you look at the table before, you see the transportation cost from those city to destinations, and you put those coefficient there. And $73, for example, from Cincinnati to Detroit, Cincinnati to Dallas, $103, Cincinnati to New York, $108, and so forth. You put those coefficient there, then you have this minimized total cost, that function right here. Then you can now formulate the constraints. As you know, we have supply constraints and demand constraints and production constraints. So those things we have to put in there. So let's first look at this graph table where you collected the data, and this will be helpful for you. So the first one is this monthly demand uh, 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 constraint. So for Detroit, we have destination Detroit, and the demand is given as $10,000. So I mean 10,000 products. So in other words, all the Detroit route, wherever it comes, it cannot be more than $10,000, right? So 10,000 items. So X11, 21, 31, and 41 is Detroit demand, and that's 10,000. Similarly for Dallas, 12,000. So we changed from 1 to 2 because 2 stands for Detroit, J2, right? And then we have to change X1, 2, 3, 4 from Cincinnati to Seattle. That has to be 12,000 items. And similarly for New York, that's 3 and 15,000 demand. And for Los Angeles, we have fours, right? And then we change the this source cities, and it has to be 9,000. Then now we have this. I'm sorry, this has to be supply. I should have changed. So supply part. So 15,000 is supply at the time. Supply from one city, such as Cincinnati, cannot be changed. So Cincinnati, the supply it has is 15,000 items. So whatever you are shipping from Cincinnati, it could be Detroit, it could be Dallas, it could be New York, it could be Los Angeles. It cannot exceed 15,000 items. So it has to be less than equal to 15,000 and 6,000 and 14,000. And here Seattle is I'm sorry, if we choose Seattle over here, and it has to be 11,000. So if you look at the problem carefully, it says the supply that they need is 11,000. So we say when it is uh, from Seattle, then it has to be less than 11 or equal to 11,000. So that's how we solve the first linear programming. And the second linear programming, however, it has a little bit different uh, shipping cost, right? So from Seattle is 60, 38, 65, 27. However, for Birmingham, it's 35, 30, 41, and 50. And you have to add this production cost. What is the production cost for Birmingham? That's $49. So instead of $35, you have to add $49, and that's $84, right? So that's for Birmingham cost $84. For Dallas, 49 plus 30 is 79. In contrast, for Seattle, 60 plus 53 is 113. So that's why you have here 113 times 41. And and then for 38 plus 53 is 91, right? 9142, right? 4 to 2. And then we have now New York. New York was 65 plus $53, 118, right? 118. So 118 times 43. That's why you have this 118 rather than 65. So I want, and 80, lastly, 27 plus 53 is 70, 80, right? 80 x 44. And that's how you got it. And for the second set of linear programming, you have to 35 plus 49, that gives you 82, 84, and that's going to be you are using instead of 113, and 30 plus 40, 79, so you're going to use 79 instead of 91, and so forth, and run your analysis again, and you will be able to find the answer. And here is the linear program result, and this is how you find, and the cost is 3,704,000. That's what it is with the Seattle, and we have to run it again for Birmingham and see what kind of cost it has and compare the two results and pick the city with a lower result because our objective is picking the city with the lowest cost.